Hello friends, welcome to CSL. So today we are going to continue with the fourth lecture in the MCQ series, and I am going to do the structural engineering part, which came in the PWD A3F examination held in the year 2018. So guys, we have already uploaded the MCQ part for surveying, estimation, valuation and concrete technology. Please watch if you did not. Okay, so today let's start with the structural engineering. Around 20 question came, okay, in the PWD 3F examination, out of which 5 from SOM, 5 from structural analysis and 10 from the design part. Okay, so structural engineering is one of the most important subject. Okay, so you do not skip this subject for any competitive examination. Does not matter if you are preparing for any APSC or other central examination. So let's start with the question that came in the examinations. Okay, so here one question is given is that the shaft subjected to bending moment and torque experiences. So it's from strength of materials. Okay, so it's given as it shaft is there. Okay, it is subjected to a torque and also a moment. Okay, so if you have the basic knowledge, you know, for a bending moment generated, then a bending stress will be generated. For a torque, a shear stress will get generated. ঠিক আছে, তো আমার এতে কি দিছে কোশ্চেনত maximum bending stress generate hobo, this is the value, maximum shear stress generate hobo, this is the value, both ANC hobo neither ANC hobo. So though আমার কি আছে M আর T আছে, তো obviously দুটা generate hobo, but maximum bending stress ইমান hobo ne, maximum shearing stress ইমান hobo ne. So let us check whether it's correct or not. Okay, so we know sigma by y equal to M by I equal to E by R. This is the bending equation. Okay, so this term do not have any reference with the problems. Okay, so if we see sigma by y equal to M by I, so sigma you get M y by I. Okay, now sigma to be maximum, this y should be maximum. ঠিক আছে, maximum লাগব. And what is y? Y is the, or this is the shaft, this is the neutral axis. Okay, there no stress is generated. Y is the maximum distance from the neutral axis. ঠিক আছে, তো আমার y max হওয়ার কারণে কত হবো distance to আমার ইয়াতে হবো, that means at the distance of d by 2. So at the d by 2 will get the maximum bending stress. So just put the formula, M will be M, this will be diameter by 2, I will be pi, you have to know the basic formula. This is the moment of inertia for a circular section. So if you calculate, you will get around 32 m by pi dq. So I am getting this one, so it's correct, but whether the maximum shear stress is this value or not, let's check. So again we know from the torsion equation, it's that T by IP equal to tau max by R equal to G phi by L. Again this term has no reference with the question. Okay, so we'll go with this equation. So T is the torque which is generated, IP is the polar moment of inertia. So polar moment of inertia means if this is the circular section, okay, at a perpendicular distance. So the direct formula is there, pi d for 4 by 32 for the polar moment of inertia of a circular section. Tau max we have to find out, and R is the radius. So if you do it, you will get tau max equal to 16 T by pi d cube. So we are getting it. So what will be the answer? The answer will be both A and C. Okay, simple. So let's go to the second question. These are all strength of materials. Okay, so it is important for both A, J. Okay, so do not miss these questions. So the question is the ratio of circumferential stress to the longitudinal stress in the walls of a cylindrical shell. Okay. So we know in a cylindrical shell, circumferential or hoop stress, it is also called, it is PD by twice T. Okay. It is the thickness, okay, T is the diameter. Again, for the cylindrical shell, longitudinal stress is PD by 40. These are direct formula has been given. So if you find the ratio, what will be the ratio? The ratio is to hoof to longitudinal, that means PD by 2T divided by PD by 40. So if you do this, this will get cancelled, 40 will get above 2T, it will be answer 2. So this is your answer. Okay. So very simple, if you know the basic, so it's very simple, you don't have to use your brain, you just have to need to know the formulas. Okay. Now again, this is again a easy question from the strength of material column part. It's given there the effective length for Wheeler formula in case of strut of length L fixed at both ends. Okay. So L effective. So if you know Wheeler, we got 4 conditions to find the critical load. First one is for hinge, it's given as L effective is equal to the L, whatever the length. Okay. So if this is a column, both the ends are hinge. Okay. So L effective is the just length. Secondly, if it is cantilever, L effective equal to L by 2. Okay. Just follow these 4 conditions, because anything can come in the examination. If it is fixed, L effective, I am sorry, it's twice L, it's not L by 2. For fixed, it's L by 2. Again, for propped, means one fixed and one hinged, means one is fixed and one is hinge, it will be L by 2 root 2. Okay. So what will be the answer? So answer will be our L by 2. For the given question, it's given fixed at both end. Okay. So this is our answer. So next we go to the 4th question. Okay. It's given as the ratio of crippling loads on column having both ends fixed to the column and both ends hinged. So the crippling load is given as pi square EI by L effective square. Okay. So you have to know the L effective. Now what are the condition is given? It's given that first both ends fixed. So both ends fixed, it's L effective equal to L by 2. Next both ends hinged, then L effective equal to L. So if you put the for first one, it's pi square EI by, it's given for the first one is fixed, so means L by 2, L by 2 whole square, which is 4 pi square EI by L square. Second will be, it's given as same L, so it's L square. So if you find P1 by P2, the ratio you will get 4. So this is the answer. Okay, simple. Now this is also a strength of materials question from bending moment. Okay. Now this is a very tricky question, and this question is very important also. It came not only in this question, in others APSC question also, another comparative examination question. Okay. So it's little tricky, so let's see how to solve this. The question is, a simply supported beam which carries a uniformly distributed load has two equal overhangs. Okay. To have the maximum bending moment produced in the beam least possible, the ratio of length of the overhang to the total length of the beam. Now, you have to understand the question part by part. Okay. First of all, say a simply supported beam which carries a UDL and has two equal overhangs. Okay. So, if this is a beam, this is simply supported. Okay. The total length, let us take it L. Okay, has two equal overhang. So, let us the overhang be A. Okay, and it consists of UDL. Okay. Now, to have the maximum bending moment produced in the beam least possible. Okay, what does that mean? Now, if for this question, if we draw the bending moment, how to draw the bending moment? Okay, first of all, you have to know tactics, because you cannot just analyze it and then solve it, the bending moment, because it will take too long. So, for competitive examination, you have to apply tricks. Okay. So, always remember, in a overhang there are two parts. The first one, the overhang part behaves as the cantilever. Okay. This overhang part behaves as the cantilever, and the middle one behaves as the simply supported. Okay. So, for cantilever, how is the bending moment? It is a hogging bending moment, like this, because if you remember, for a cantilever, if this is then UDL, so what will be the bending moment diagram? Like this. Okay. So, this is the bending moment in the overhang part, and this is a simply supported beam. So, it will be this type. Okay. This is the bending moment. This is, and it will be a curve one, because overall it is UDL. Okay. So, it will be a curve one, parabolic curve. Okay. So, what is the question? To have the maximum bending moment produced in the beam least possible. Okay. Now, if this is our question, okay, this is A, and overall is L. Okay. So, for this is our bending moment. Now, if we increase the overhang from both the side, okay, this is A, because it is equal overhang. So, if we increase from this side, this it will also increase. Then what will be the bending moment diagram? This will be. Okay. So, if we increase the overhang, this bending moment, listen carefully. Okay, this bending moment will increase. Okay, as we increase the overhang. Now, if we decrease the overhang, okay, if we decrease the overhang, so how is the bending moment diagram? Now, it will be minimum here, means less here, and the bending moment will be more in the central position, which is opposite to the. Okay. Now, a situation will come where this bending moment and this bending moment are equal. Okay. This one and this bending moment is equal. This position will give the least bending moment. Okay. Because if you then remove the overhang, or in this area, this bending moment will increase. If you decrease the overhang, this one will increase. So, a position will be there for the bending moment, for the overhang, that this moment and this moment will be equal. That is the least possible bending moment which may be produced in the beam. Okay. So, this is the condition, you have to understand the question. Okay. So, এতিয়া কি হ'ব আমাৰ bending moment diagram to আমি first draw কৰো. So, this is our question. This is A, this is A, this is, if total is L, this will be L minus twice A. Okay. Now, first of all, the bending moment and the reaction. Okay. So, reaction you can find out with the convenient your method of finding the reaction taking moment about this point or this point, or if you see the loading is symmetrical, okay, if it is W, okay, if the loading is symmetrical, just divide the total load in the reaction. So what will be the total load? Total load will be W into L, total is L, so total load is WL. So the reaction will be how much? R1, just divide it, W1 by 2 into 2 parts. So, okay, this is one of the trick to find the reaction in the examination, because it is a competitive examination, you cannot take time. So as the loading is symmetrical, only for symmetrical loading, otherwise the answer will be totally wrong, okay. As this is a symmetrical loading, because it is overall, this is, so this will be WL by 2, this will be WL by 2, okay. Now what will be the bending moment? The bending moment will be like this, okay. So to find this one and this one, okay. So let me take, okay, so a section is there, okay, this is A. So what will be the bending moment at this position? X1. So bending moment, let us take this as point A, this is point B, okay. Bending moment at A equal to, so take all the load from the left side or right side. So from left side it is simple, only what is the load? Total load is W into A, because it is an UDL. So W into A is the total load, and where it will act? In the CG, okay, that means into A by 2, W A square by 2, okay, and this is an hogging, that means it will be negative, okay, or you can write hogging bending moment, okay. Next, where we have to find out? At this position, let it be C, okay. Let me do in the second part. Okay, so this is the UDL. So we have to find out bending moment at this position. This distance is A, and this whole distance is L minus 2A. So what will be this distance? L minus 2A by 2, okay. So what will be the bending moment? First clockwise one, reaction R1 into the distance is L minus twice A by 2, minus there is a load also. So what will be the load? W into what is the length? Total length is L, we have to find out the midpoint, so it is L by 2. Again, where the CG will act? At the CG of this length, so half of this length, okay. So you just go with the convenient method, so you will get, so R1 is WL by 2 to L minus 2A by 2 minus W L square by 8, okay. So what we have to do? We have to now equate it. So first what we have got? We have got is W A square by 2, okay, W A square by 2, do not take the negative sign, okay, it is just a symbol for hogging, okay, it's only for hogging we have shown negative, but when to solve we have to just take the arithmetic value, not the algebraic value, okay, just the value we have to take. So W A square by 2 equal to WL by 2 into this one, WL by 2 into L minus 2A by 2 minus WL square by 8, okay. So if you see where all the W get cancel, A square by 2, here you will get L square minus 2AL by 4 minus L square by 8. So if you do it, you will get, take LCM, 2L square minus 4AL minus L square. Okay, so this you can get cancel, 4 again cross multiply. Please don't do mistake, okay, in the equation, do slowly, you will get the answer. L square minus 4AL, so L square minus 4AL plus 4A square, sorry, minus 4A square equal to 0, or you can take 4A square plus 4AL, if you take in the other side, minus L square equal to 0. We have to find A. Okay, so that is the final equation, 4A square plus 4AL minus L square equal to 0. Okay, so here A is the variable and L is the constant. Okay, so if you know this formula, ax square plus bx plus c equal to 0, this is quadratic. Okay, so you should know all this, b square minus 4ac by 2ic, this is the formula. So here a equal to minus 4l plus minus 4l whole square into 4 into L minus minus plus it will come and 2 into 4. So if you see something, you will get like this, minus 4L 4 root 2 L by 8. So if you just solve it, you will get finally root 2 minus 1 by 2 into L. Okay, so A will get this value, root 2 minus 1 by L. So what will be A by L? It will get root 2 minus 1 by 2, root 2 you will get around 1.414, you should know the value. Okay, or you can just use the calculator. If it's not allowed, just you can just remember, okay, root 2 equal to 1.414. So if you do, so here I am solving, A will be 1.414 equal to 0.414 divided by 2, and it will be 0.207 A by L. Okay, so this is the answer. So it is the little tough one that came in this examination. Okay, so this is your answer, 0.207. So I hope you have understood this. Okay, so this is all the 5 question came in the SOM part. The next one, in the next part, I will continue with the structure analysis part. Okay, and then we will just move to the RCC, the design part. Okay, thank you. Thank you everyone for watching the video. Please follow our page for more civil engineering videos. Please follow us on Facebook. Do not forget to hit the like, share and subscribe button, and press the bell icon to never miss an update from CSL. Thank you.